All right, section 11.5, applications, interest and mixture. Let's just do a couple of examples from this. Kind of put this in here for the interest problems, just so you kind of understand a little bit more. Some people don't understand finance. You maybe haven't taken an accounting class, probably not. Principal, amount of money invested or borrowed. Rate of interest, annual rate. Time, how long is it going to take you to pay it back. Interest, how much you got to pay extra. Like when you buy a car for $1,000, you pay it off over 5 years, but you end up having to pay like $1,500 because the bank or the car company wants a little extra money because they did loan you the money. So that's kind of what that stands for. Here is the equation for interest. Okay, so let's just do a quick little couple of example on this one. Okay, James has 2 investment accounts. Let's come in here. He has 2 of them. Okay, one pays 6% interest and the other pays 10% interest. He has 1,000 more in the 10% account than he has in the 6% interest account. In 1 year, the interest from the 10% account is 260 more than the interest from the 6% account. How much does he have in each account? Okay, in this scenario, this is interest earned on like an investment. Okay, which means like if I have, once again, like on this one right here, if you have $1,000, you put it into the bank and they say you're going to get 10% interest annually, that means at the end of the year, instead of me just having $1,000, I'm going to have $1,100 because the bank's going to give me an extra $100. So let's assign each of these a variable. Okay, let's just be very intentional in how we do this. We got to have an x and a y. So let's do x equals the amount P, remember that's the principal, of the first account at 6%. Let's do y equals the amount P for interest at 10%. Okay, well, continuing on in that vein, that means that x is going to equal 0.06x. Okay, that's going to be the interest. Okay, on the first account. Y is going to be 0.10y. That's going to be the interest on the second account. Remember, just as kind of a review, I'm just going to use one little example up here. I'll do it in red. 6%, okay, to turn that into a decimal, okay, you're going to divide it by 100. Okay, so whenever you divide it by 100, or basically take this and move the decimal place over twice. That's where I'm getting that 0.6. Okay, move decimal 2 places to the right. Okay, that's to go to decimal. Just a quick little review, in case you don't remember. Slept since then. Trust me, even I forget to do that sometimes. I'll be doing calculations and be like, what? Wait a minute. Oh yeah, forgot to change it to a decimal. Well, let's now make a system of equations. Let's do, first off, y. And why am I using y? Well, we're going to do y first because y equals x plus 1,000. Where am I getting this 1,000? Let's remember that right here, he has 1,000 more in the 10%, okay, account than in the 6%. Well, more than. So I need y equals, there's the first account. He's got 1,000 more in y than he does in x. So there's our first equation. Second one, we want to make sure to put everything in just order, like how we did, basically kind of like how we did the bus one. We're going to have 0.10y, okay, minus 0.06x equals 260. Once again, why am I using a minus? Let's look right here. In 1 year, the interest from the 10% account is 260 more than the interest from the first account. Well, to have more than something means that you need to subtract something off from the second number to find out how much more than. Well, we already have that. We know that this second account has 260 more than this first account. So that's why I use the subtraction. Well, they're nice enough here to go and give us a y equals. So this once again is going to be substitution. And let's go down here and let's go and substitute it in. Scroll down. Before we do that, I want to show you something. Look right here. This is not very happy looking. I mean, if you're going to use your calculator a lot, I get it. Go ahead. You can. Okay, so once we come in here and substitute, I want to get rid of those decimals. Okay, so let's substitute first. Let's take this equation here and put it right here. So we're going to have to rewrite. We're going to have 0.10. Well, we're not going to have y anymore. We're going to have this x plus 1,000. Be very intentional. Minus 0.06x equals 260. Here's how I want to get rid of the decimals. Okay, let's make these whole numbers. I like whole numbers a lot more than I like decimals. Can you do this in decimal form? Yes. I wouldn't suggest it. Take each one of these. Let's go ahead and change to a different color here. Let's multiply everything by 100. Well, if I come in here and multiply everything by 100, I'm going to do it here. I'm going to do it here. I'm going to do it here. Notice what happens when I multiply this by 100. That's going to move the decimal place over twice. So then I'm going to have 10. I do not have to come into here. Okay? If I'd have wanted to, I could have distributed and then multiplied everything by 100. I decided not to do that. So that's going to keep everything here the same. So you're going to have 10 x plus 1,000 minus, well, instead of 0.06, now I'm just going to have 6x equals, add 2 zeros to that, instead of 260, we're now going to have 26,000. Now we can distribute. Take this 10, distribute it to everything inside there. When we do that, we're going to get 10x plus, not just 1,000, we're going to have 10,000 minus 6x equals 26,000. Notice I'm still being very intentional. Around the first of the year, I probably said to y'all, keep doing every step. Don't skip steps. That way you can always follow your ladder. Okay, here I'm going to combine my like terms. Here, combine those, and then here I've got a positive 10,000. Well, I'm going to subtract off 10,000 here, and I'm going to subtract it from here. So 10x minus 6x is going to give me 4x. This is going to reduce. This right here is going to be 26,000 minus 10,000, which is going to give me 16,000. Continuing on, I have 4 multiplied by variable x. Well, to get rid of that, I will divide by 4 on both sides to reduce this out, and that is going to leave me with x equals 4,000. Now, we're not done yet. We're going to back substitute. We're going to take this equation, we're going to take this x and put it back into our first equation, which is going to be y equals, well, instead of x, I'm going to put 4,000 plus 1,000, and then we're going to get y equals 5,000. Basically what it's saying is the first account, the 6% interest account, okay, it has $4,000. The 10% interest account has $5,000. So that would be the, right here, would be the principal. Principal. I think. Probably misspelled that. But let's continue on. Let's do a mixture problem real fast. Okay. This one right here, I'll let them go ahead and give us the X and Y. Okay. We have two different things, X and Y. Let's go here and start kind of filling this out. How many ounces each of a 10% salt solution and a 15% salt solution must be used to produce 50 ounces of a 12% salt solution. Basically, you have a big, if you've taken biology or taken these sort of labs, you've got a beaker full of solution over here that has 10% salt. You have a beaker here with 15% salt. I'm going to dump them in to a middle container, but I want that thing to have 12% salt solution. The rest of it's going to be diluted in water, distilled water, or whatever. How do we figure it out? Well, once again, let's make a little table here. Here's my 10%. Well, what's my 10% going to be? We've already assigned it to the X value. We're going to multiply it by what? 0.10. 10%. Remember, we're going over twice. We're changing that over to a decimal. What's that going to equal? 0.10x. Well, how about our 15%? It's going to have y. Multiply by 0.15. Move the decimal place over. Okay? That's now going to be 0.15y. Well, our 12% solution, that's going to be the amount. Well, it tells us in our problem up here, it tells us we need 50 ounces. Okay? How much of a percent salt? Well, they want us to have 12%. Well, how much do we find out of that? Well, it's going to be 50 multiplied by 0.12, which is going to end up equaling 6. Okay? So that's the amount right there. Now let's just put it into a linear equation, being very intentional. Once again, we're going to have x plus y, because we need both of these. Let's write it right there. X plus y. What does it need to equal? X plus y needs to equal 50. Okay? Well, then what? Well, all of these need to equal this 6. So my next one can be 0.10 x plus 0.15 y equals 6. Okay, I had to do just a little bit of editing real fast. Notice on the second equation though, I'm going to come in here and I'm going to multiply everything by 100. So if you just saw that up here, I was having to make a little correction. When I do that, okay, let me come back up here. When I do that, we can rewrite this as x plus y equals 50. Well, when I multiply this by 100, I'm going to have 10x plus 15y equals 600. Notice we can't really solve for y on this one, so I can't do any substitution. But what I can do, if I choose to, which is the way to go, come in here, multiply everything on this one by -10. When we do that, we can continue on, and we will get -10x plus let me rewrite that, -10y equals -500, and then just recopy here. And if you recall, this is just the addition method right here. When we do that, these are going to cancel. Okay? -10 plus 15 is going to give us 5y. -500 plus 600 is going to give us 100. When we solve for y, basically divide out 5 on both sides, we're going to be left with y equals 20. This 20 right here Okay, notice our Y, that's the amount of the 15% solution. So let's put this back, this 20 back into our original equation here. So I can take x plus 20 equals 50. I can subtract 20 off both sides. Okay, when I do that, I'm going to get x equals 30. So my final answer is I need 30 ounces of the 10% solution, and I need 20 ounces of the 15% solution. So hope that helps out. There we go. We'll move on to some hogs.